The probability that man aged 65 live to 75 is a 0.65. What is the probability that out of 10 men, now 65 at least 3 will live to 75? As in this example, we have asked what is the probability that out of 10, that means here number of trials are 10. As trial means here we have given 10 men are live now at age of 65. How much of them, at least minimum we have asked 3 out of these 10 will live to 75. Now here living at age 75 is a event. Now the probability of man aged 65 to 75 is a 0.65. So the probability of event is a 0.65, which is here probability of success. That is P is here 0.65. Now Q is equal to 1 minus 0.65 is a 0.35. As N is a 10, which is a small, and P is also 0.65 is a comparing large. So using by binomial distribution, we evaluate probability of R number of successes as a NCR P raised to R into Q raised to N minus R. Now here, as we have to take R at least 3, as we know if at least is a given, so we use inequality as a greater than or equal to. Here R is greater than or equal to 3, so R has a value more than 3. Now value of R will be 3, 4, 5, 6, 7, 10. That means all 10 mans will allow you, or all R is a 3 means all 3 out of 10 will allow you at age of 75. R is a 7 means 7 out of 10 will allow you at age of 75. At least 3 means we have to find R is greater than or equal to 3. Now R is greater than or equal to 3 means R has a number of value. So is here again a complement as to evaluate probability of R greater than 2 equal to 1 minus probability of R less than 3. Now 1 minus probability of R less than 3 means R has a value 0, 1, 2. Okay, so as these are independent events, we put it as a P of 0 plus P of 1 plus P of 2. Now value of P of 0, as putting R is equal to 0 in this formula of NCR, as N is equal to 10 C 0, P is a 0.65 raised to 0, Q is a 0.35 raised to 8 minus 0, 8, plus now P of 1 by putting R is equal to 1 this formula, as N is equal to 10, sorry I put here wrong, as R is N is here 10 minus 0, 10 C 1 into P again 0.65 raised to 1, Q is a 0.35 raised to 10 minus 1 is a 9, plus P of 2 as a 10 C2, P is a 0.65 raised to 2, Q is a 0.35 raised to 10 minus 2, 8. Simplifying this by using calculator, we get the answer as 0.9952. That means probability of allowing at least 3 men out of 10 is a 0.9952. Assuming that 2 in 10 industrial accidents are due to fatigue, find the probability that exactly 2 out of 8 accidents will be due to fatigue. Now here we have given that we have to find probability of exactly 2 out of 8. That means here number of trials are 8, and out of 8 trials we have to find 2 number of successes, as we have given 2 in 10 industrial accidents are due to fatigue. That means the accident due to fatigue is an event, and probability of that event is here probability of success P. Now as we have given 2 in 10, that means 2 by 10 is our probability of successes. 2 by 10 is here, we can put as a 0.2. Now Q is a 1 minus P, that means 1 minus 0.2 is a 0.8. As we understand here, number of trials are 8 which are less, and P is a 0.2 which is a as we know probability is always less than 1, and as the probability of success P is here 0.2 which is a large value compare. So we use here binomial distribution, as probability of R number of successes is NCR P raised to R into Q raised to N minus R. Now in this example we have to take here R as a 2, as we have to find exactly 2 out of 8 accidents. So P of 2 is equal to by putting the value of N as 8, 8C2, P is here 0.2 raised to R, that is 2, into Q is a 0.8 raised to 8 minus 2. By using calculator we have to evaluate this value, and the value will be 0.2936, which is our answer. If 20% bolts manufactured by machine are defective, determine the probability that out of 4 bolts are drawn. Now here a machine is manufacturing bolts. A number of bolts are manufactured. For checking defective or in good bolt, we take a sample of 4 bolts. That means we check 4 bolts here. That means in solution we put N as a 4, as sample are number of, in sample we take only 4 bolts, that is 4 trials are will be taken. Now the bolt will be defective or undefective. Here bolt is a defective is a event, and that means probability of success is a probability of getting defective bolt. Here as a P is a given 20% bolts are defective, that means 20% is represented by 20 by 100, which means 0.2. Here probability of success will be 0.2, so Q will be 1 minus P by putting 1 minus 0.2 as a 0.8. Now you can observe the N is a small and P is a large. So by using binomial distribution we evaluate probability of R as a NCR P raised to R into Q raised to N minus R. Now in example we have asked first 1 is a defective, so take R is equal to 1, so P of 1 by putting 1 in NCR, as N is equal to 4 we get 4C1 into P is a 0.2 raised to 1 into Q is a 0.8 raised to 4 minus 1 is a 3. By using calculator we can simplify this, as answer is a 0.4096. So getting 1 defective bolt out of 4 bolts drawn is a 0.4096. Now number 2, at most 2 are defective. So at most 2 is inequality. As we know, R we have to take here R as less than or equal to 2. As we know, for at most we use greater than or equal to, for at least we use greater than or equal to, at most we use less than or equal to. That means R has a value less than or equal to 2, means 2, 1, 0. 0 means no defective bolt, 1 means out of 4 1 bolt is defective, 2 means out of 4 2 bolts are defective. We have to find probability of at most 2. So P of R less than or equal to 2, we can define it as using complement, but using complement we have to find the value of 1 minus P of R greater than 2. That means R is a value 2, 3, 4 here. So again there are number of values of R, so we use directly P of R less than or equal to, means P of R has a value 0, 1, 2. Now these are independent events, so we have to take P of 0 plus P of 1 plus P of 2. Now putting P of 0 as R is equal to 0 in formula, as N is equal to 4, we get 4C0, P as a 0.2 raised to 0, Q as a 0.8 raised to 0 minus 4 is equal to 4, plus P of 1 as a 4C1 0.2 raised to 1 0.8 raised to 3, plus P of 2 4C2 0.2 raised to 2 and 0.8 raised to 2. By using calculator we can simplify this, and answer will be 0.9728. That means at most 2 volts out of 4 defective will be 0.9728.